we ready? We're going to start to learn how to solve by square root. So you already have a certain solving method. That's not really going to change. We're still solving. But before, so all the way up until this point, all of our solving, in other words, our finding zeros, that's the other phrase that we had for it, right? So all of our solving, in other words, finding zeros, was done by factoring. That's what we've been doing for the past week. We had to factor in order to get those zeros. Do make sure we're taking notes. Helps us out. The question becomes, what if it cannot factor? What if you don't have a difference of squares? What if AC method won't work? Because not everything will factor. So we need to know, what can I do if that's not the case? Because I can still solve it. So our first strategy is what we call the square root method. That method only works if you only have an x squared. You can't, oh, that's kind of nasty, x squared. You can't have any other x's present. It has to only be x squared. If it's only x squared, then it will work. Okay? Before we get to actually solving, and I only have really 2 examples for solving them, I need to kind of go over a little bit of background information regarding square roots, some things you're expected to know walking in when you solve square roots. And this really is going to follow us into next week as we do other methods that have square roots inside of them. Can I erase? Not quite yet. So our background that we're going to cover, number 1. We're going to talk about simplifying them. We're going to start with what you had in the warm-up. So the square root of 25. You guys told me that you knew that that square root, because we knew that 5 times 5 is 25, so therefore we can declare that the answer is 5. So the question becomes, what happens if that's not a perfect square? What happens if it's the square root of 12? Well, the philosophy is going to still be the same. Some books teach you to see the square inside of the number. I never do that. Especially as the numbers get bigger. The way that I do this is by building a factor tree. So we're going to like pull in our sort of elementary school math at the moment. What multiplies to give me 12? So I had 3 and 4 first. If you did 6 and 2, you'll get the same thing. What multiplies to make 4?
2.
The key to the factor tree is that you're only looking at the end of the tree. So what we're going to do is we're going to replace that 12 with the 2 2s and the 3, and I'm just going to put it in order. Now, how did you know that the square root of 25 was 5? Well, you did this. You had 2 5s. Same idea. I have 2 2s here, so I can square root that piece and leave behind the 3 that I cannot. Now, that's sort of the mathematical way of doing this. The way that I always teach this is that this is a square root. It kind of looks like a little house, right? And the door is a little bit ajar, maybe. And in this house, there's a very, very strict mother who says the world is a dangerous place outside. So you cannot go outside unless you have a buddy. And I don't care if you can find a group of 3, you're still only leaving with a buddy. That's the rule, okay? So if you can find a buddy, then you guys get to leave the house. Any loners have to stay in the house. They cannot associate with anybody. They are grounded. No internet, no phone calls, no nothing. Make sense? That started. You guys do not look like you appreciate this. All right. Let's do a more complicated one. So this will be a little bit bigger than anything you'll see in your homework. 360, we're still going to do the factor tree. What multiplies to make it? 60 and 10 will not work, no. 36 and 10. Yeah, I'm hearing a lot of things in there kind of jumbled, but that's the one I heard is 36 and 10. All right. Again, no matter what you pick, you'll still get to the same result. What is the 36? 6. Let's pretend you don't notice your pair and you just keep going. So what's the 6? 2 and 3. And the other 6? And the 10. Now again, the key to this is to remember that I'm only looking at the end of my tree when I build my square root. Again, I want to put it in order, so I have 1, 2, 3 2s that I'm going to write down. I have 2 3s, and I got a 5. I need a buddy of a 2. I only have 1 buddy for 2s, and I also have a buddy of 3 for my 3s. So the 2 and the 3 comes outside. The loner 2 and the loner 5 have to stay inside. They have no friends. 2 times 3 gives me 6. 2 times 2 gives me 5 because you multiply together the duplicates. So if I have 2 things coming outside, they multiply together. If I have 2 things left inside, we multiply them together. So this square root simplified is that square root. Does that make sense? Any questions there? All right, so the next part of the simplification, really quick, is sometimes we multiply square roots together. So what if I have 2 square root of 3 times the square root of 3? All right, what number is in front of this square root? Let's start there. A 1. Now, here's your rule. Remember, you are not allowed to associate with anybody outside the house if you are inside the house. You are grounded. No phone calls, no cell phone, no nothing, no TV, right? You have to stay in the house, okay? So when I do this, you're going to multiply the numbers on the outside together, and I'm going to multiply the numbers on the inside together. That gives me 2 square root 9. But what's the square root of 9?
3.
2 times 3?
6.
Sometimes you'll still have buddies left over inside. That's okay. You'll still have the square root there. The only time you lose the square root is if you could take that perfect square. Questions there before we do the next simplification? All right, so let's do the square root of everybody's favorite, 1 over the 1. If I'm square rooting a fraction, we're going to end up square rooting the top and then square rooting the bottom. Square root of top is a 1, square root of the bottom is a 9. The last thing comes out of this, which means, what if that didn't quite work? So let's say I'm taking the square root of 1 over 3. So I try to do this. I square root 1 over square root 3. What's the square root of 1?
1.
Square root of 3, I have no idea, right? I can't do that. But we have a rule in mathematics that says you can't leave that down in the denominator. It's not going to work. So I need to get rid of it. What could I multiply by the square root of 3 that would in essence sort of get rid of that?
3 squared.
You're on the right track. I need another 3, right? I need that buddy. So I'm going to multiply by the square root of 3, though. What do I do at the bottom? I have to do the top of a fraction in order to keep it the same value. So that means on the top I have 1 times root 3, which is just root 3. On the bottom I have root 3 times root 3. That gives me root 9, which I can go ahead now and take. Whoops, sorry. And that gives me 3. Does that make sense? The beginning of your assignment, I would say like almost half of your assignment is all of this sort of simplification things. And the main reason for that is because it's going to follow you all throughout next week. Also, when we change methods, we'll have different areas where we'll have to simplify them, so they really want you to be strong in that. All right. So, moving on to the second piece of background information that we need. The second piece of background information is that if we square root, so our square roots and our squares are opposites of each other. In other words, they undo each other. So if I'm looking at this, if I'm looking at 3 squared, I get 9. But if I square root 9, I get 3. They undo each other. So that if you have an equation where you're asking for x squared equals 9, and you want to know what that is, in order to undo that square, we are going to square root both sides. I'm not going to do that right now because we need background number 3 to do it. Can I erase? Not yet? All right, we're good now?
Yeah.
All right. Background number 3. If x is squared, there is more than one answer. For instance, if I tell you x squared is equal to 16, all I'm telling you is that if you take a number and you multiply it by itself, I get 16. So what's an answer for that? Yeah, because 4 times 4 gives me 16. The problem with this is that there's another answer. What times itself that's not 4 will give me a positive 16. Yes?
-4.
Good. -4 times -4 also gives me positive 16. Based on their question, do you know which one it is? No, because both of them will work.
Plus or
So
minus.
you don't know which one, again, because both work. Which means that when you square root a squared x, I should say. When you square root the squared x here, you must include the positive and the negative. In other words, your answer for this problem would be x equals 4 and x can equal -4. Now, if you want to shorten that answer, we shorten that with what we call a plus or minus sign, meaning that symbol right there is meaning it could be either positive or negative 4. Either one will work. This is a solving problem, which means all of the square roots you have at the beginning of your problem, if I give you saying to simplify the square root of 12, notice we didn't do anything with a plus or minus sign, right? Because I don't have that problem. The only time I have this problem is when I'm square rooting that square. Then I have to throw a plus or minus sign down. Does that make sense for 3 before we solve? We only got 2 examples. Can I erase? Hello. So, example number 1, and like I said, we'll do 2. X squared minus 1 is equal to 17. Whenever you get a problem, you need to first check if it factors. We're not going to do that here because this will not. Whoops, I went off my screen. You have to first check it if it factors. Because that's your first option, it's the easiest one. So if you remember, this week, really, a couple days ago, we were doing difference of squares on them. The problem is if you try to set it equal to 0 and solve it, it's not going to be a difference of squares. It's not going to work. The second thing that you need to check is that you only have an x squared. Because again, I cannot do this method if I have any other x's that are present. Okay? Zach, you still with me?
Yep.
Are you sure? Positive?
Very positive.
Got everything written down? Alright, so my first step is I'm going to get x squared alone. In other words, there's a lot on this side with the x squared. So you're going to solve this just like it was a normal x. So how would I get x squared alone? Plus 1. So that gives me 2x squared is equal to 18. Now what?
Divide both sides by 2.
Good, divide both sides by 2, and I get 9. Oh, yeah. And then? Question?
Well, do you want the answer?
Oh, no, I just thought you had a question. Yeah, so I'm going to square root both sides. The moment that you throw this square root down, do yourself a favor and throw down your plus or minus sign. Square root of an x is an x. Square root of a 9 gives me plus or minus 3. If I can't take that square root, that's where you would have to break it down by doing the factor tree like how we began. Okay. Questions with that one before we go to number 2? All right. So last example. Is 1/3 parenthesis x plus 5 squared is equal to 7. All right. So, my question here, what is being squared? Yeah, that whole thing, right? This whole chunky thing is being squared. Make sense? So I'm going to kind of just ignore the middle part for the minute. I need to get the square alone. So what is on the same side as that square right now?
1/3.
The 1/3. Make sense? That 1/3 is being times by my square. So how do I get rid of it?
Distribute it.
Hmm?
Multiply by 3.
Yeah, so you're either dividing by the fraction, which is the same as multiplying by the reciprocal, which is 3. So I'm going to take on both sides, and I'm going to multiply by 3. So that's the getting rid of this 1/3 step. Because 3 times the 1/3, those 3's are going to cancel, and that leaves me with the x plus 5 squared equals 3 times 7 will give me 21. Now, be careful. We're going to sort of make a little note here. You cannot distribute the 1/3. My question to you, why? Why, if I distributed the 1/3, would that be wrong? What's stopping me? The exponent. Because in order of operations, what comes first? Multiplying or exponents?
Exponents.
Exponents. So I can't go multiplying this inside because you're breaking order of operations. You're multiplying before you take care of that square. Okay, so my only option was to get rid of the 3. Does that make sense? All right, now how do I get rid of the square? Square root both sides. I had to get the square alone because I square root a side. There is no such thing as square rooting individual pieces. You have to square root the entire side. Again, the moment you throw that square root sign down, you might as well throw a plus or minus down. All right, so square root of the square drops the square. I'm left with just x plus 5 equals. Now, if I did my factor tree, what would multiply to make 21 again?
3.
Are those buddies? No, I don't have any buddies there. So that means that nothing leaves the house, and I'm left with just plus or minus square root of 21. Now here's my question, am I done?
No.
How do I know I'm not done?
It's not.
Yeah, I don't have x alone, I still got the plus 5. Perfect. So how do I get rid of the 5?
Subtract it.
So subtract it from both sides. Now, here's the deal. If I write the 5 in the back, it becomes a little weird as far as, is that supposed to be underneath the square root or not? It becomes a little tricky, especially if we're a little sloppy with our square root sign. So the rule is that we're going to write that negative 5 in front of the plus or minus square root of 21. This is still 2 answers, they're just 2 decimal answers, which means that if you went to your calculator and you did negative 5 plus 21, that would give you a decimal. And then you would take negative 5 minus the square root of 21, that would give you a second decimal answer. So you're still getting 2 numbers, you just don't know what they are because you don't know what the square root of 21 is. Does that make sense for number 2? Yes.
Did we over those on our homework? How
Yes,
far-
they're at the end.
How far do we have to solve it?
Just to here is fine. Any other questions with it? All right, so take out your assignment from, you already